All right, so we're ready to begin. So in today's class, we are going to discuss these topics, and I have only about half an hour's time, so we should move on quickly. So the first thing we can do is we can start with a review of the real and apparent depth. Nothing much to do in that sense, but just to get an idea that there's going to be a phenomenon of the real depth and apparent depth, why it occurs, what are the reasons, and what are its effects. Then I have planned on a quiz after that. This is something I tried. I'm trying today. Permal sir suggested that we can use Google Forms to create quizzes that can then be mailed to the students. They can respond in real time and feedback can be given. So this is more or less an experiment on my part. I'm going to send you a short quiz by email, which I'll give you a few minutes to do the work, and then you can respond with your answers. And apparently, it can also then be uploaded. It can automatically do some diagnostics work on that and give me some statistics. I'll work on it over the day and get back to you with the results tomorrow. We need to discuss the exercise 4C. Matlab, I am going to give the assignment today to be completed tomorrow, and if time permits, we will take up critical angle and total internal reflection. So to start with the review, um, where is the camera? Hey. Mm-hmm. Oh, I'm having some trouble. All right. So back to the screen now. Okay. So basically, a review of what happens is that of the real and apparent depth is that in the textbook, the definition is given as an object placed in a denser medium when viewed from a rarer medium appears to be at a depth lesser than that of the real depth, and this is because of refraction of light. So the key point is the definition of what happens in real and apparent depth. That is, where is the object placed in a denser medium, where is it viewed from the rarer medium, and what happens is that it appears at a depth which seems to be less than its real depth. What is the reason this happens? It's very simple. It's just because of refraction of light. So in terms of the ICSE, this is how you need to know the phenomena. Now, moving on a little bit, we'll look at two equations that you require to know in terms of problem solving for this chapter, which is in page 89. Okay. Page 89, and there is a derivation of how you actually arrive at that equation, but the main thing uh, is to know that the refractive index uh, of the medium from which you are viewing to the medium in which the object is placed is equal to the real depth the ratio between the real depth and the apparent depth. Now, the derivation that is given is a correct derivation. It's a detailed derivation, and there should be no problem if you work through that derivation in understanding how this happens. That the refractive index from air into the medium that you are looking into will actually give you the ratio between the real depth and the apparent depth. Now this allows you to then use this equation to find out any one unknown when two of the other unknowns are given. And so now you can also rearrange this equation to say apparent depth. So I'm going to apparent depth and real depth. I'm going to put it like that, otherwise I'll have to write the whole thing down again. The apparent depth can then be found out by dividing the real depth with the refractive index from air into the medium. So this is one useful form of the equation. Remember, I had told you people when you were here in the classes to actually have a section in the back of your notebook where you are going to write down the equations, the equations that are part of your syllabus that you require to know, and also the diagrams, the page numbers and the number of the diagrams. So please continue this while we are having this discussion also. Okay, so Anjali is here apparently, and Tanvi is trying to call Saumitri, but he is not picking up. Okay, that's fine. You can also try to get in touch with him later. All right, and so this is one equation. There is one question that has been given in the exercises later, in which you can apply this equation. So there is another equation now, which is given on the other side of the same page. So this is still on page 89, which is the shift that occurs when you look in from the rarer medium into a denser medium. So the shift is actually the difference between the real depth and the apparent depth. Okay, and this shift can also be found by the product of real depth times 1 minus 1 by the refractive index from air into that medium. Okay, so this is also an useful equation to remember. The applications for both these equations are very straightforward. You only need to identify from the question what is the real depth and what is the apparent depth, and then it's just a plug and play. So you just put in the numbers, take care that you keep the units consistent. If it's millimeters, keep it in millimeters. If it is in centimeters, keep it in centimeters. If it is in meters, keep it in meters, and the answer should pop out. So any combination of this, again, this equation also contains three unknowns. So if you are given any two and ask the third one, you should be able to work out. It's going to be very rare that they are going to give shift and real depth and ask you to find out the refractive index of the medium. That will be a little harder to manipulate. But otherwise, if shift is asked for and real depth and refractive index given, or real depth is given and shift and your refractive index is given, that shouldn't pose any problems at all for you to figure it out. So is that clear? Any doubts about it? Yeah, a lot of
refractive index.
Yeah, Avnish, what's your question? Okay. All right. So Avnish didn't have a question. Now we move on to the dependence of the shift on what factors. So there are three factors given in your textbook on which the shifting depends. The first one is, of course, the refractive index. So obviously, the greater the refractive index, the more bending of light. So therefore, there is going to be a greater amount of shift. The second point is thickness of the material. Let me put it as thickness of the denser medium. So obviously, the larger the thickness, that means let's say the deeper the water, and the deeper the object is inside the water, the shift is going to be greater. And the third point is wavelength of the light. So
So,
if you have a different color of light, then for the same depth and the same refractive index, you are going to have a different amount of shift. Yes, somebody wants to ask something.
yeah. So, can you repeat the second point? I couldn't hear you very well.
So the thickness of the denser medium, the shift depends on the thickness of the denser medium. What that means is that if you have water to a certain a depth, so let's say for example, um, I don't know if I'll be able to draw it in this time in this frame. Okay, let me try it on paper now. So if you have an object um, at the bottom of the container, and
Yeah.
let's say another okay, I'll just draw another container, but in this case now the object is here. Okay, so
Okay.
as I was showing to you yesterday,
Yeah.
somebody's mic is on, so I can hear. Okay, so this is just a sketch to sort of illustrate, so I haven't done it with a great deal of accuracy, but uh, thematically you should be able to see that this is the shift, right?
Yeah.
Now with a greater depth, because the light has to travel for a longer distance before it emerges, the divergence of these two rays is going to be greater, right? So it's coming like this. Whereas over here, since it has to travel a shorter distance, the divergence being lesser causes a lesser amount of shift. So the shift in this case is lesser. Do you get this?
Yeah.
A and case B. All right, so that is why the second point is relevant, that is the thickness of the denser medium. So by thickness of the denser medium, you can also write the depth of the denser medium. But what if you are thinking about glass, right? So if you're thinking about a glass slab that has been placed, right, then we are talking in terms of the thickness of this glass slab, which is what is actually causing the shift to occur. Okay, like that. And I don't know. Oh yeah, I can try doing this. I'm not sure it will work, but I put a sort of blue dot there and I place this glass slab. Okay, I don't know if you are able to see the difference in the shift. Is anything visible in terms of the shift? Can you see the can you see the change in the depth?
Kind of.
Yes, slightly.
Slightly. Now can you see it?
Yeah.
See, when you see it from the side and when you see it from the top, you can see a difference, right? You're looking at the same dot. And in fact, I can also draw a dot right here. So you can see three different dots. and the way the shift works. Okay, so obviously the entire height of this forms the thickness, then obviously there is a much greater shift. All right, shall we carry on now? Somebody's making some whistling sounds. Very weird. OnePlus 7T Pro. Is that Diva?
Nice try.
Okay, so now what I'm trying to do is I'm trying to send, so just bear with me for a few moments. If anybody has any questions, you can ask. I'm going to try and send the quiz. So this is an online quiz and it will be mailed to your account. So you open Google Forms and you answer it directly on the Google Forms. Okay. So see if this works. So this is just a kind of basically an experiment. And I hope it works.
So,
Yeah.
Arun, so how long will be this classes for?
Till 10:50 because Amrish sir will come on next.
I mean, I know, I mean till 10:50, but like for how much time? Like till April or something.
Till the cows come home, man. Why?
Okay,
You have to travel somewhere.
No, I'll just ask it.
Let's say till we finish light at least, or I get infected by coronavirus and then that's the end of it.
Sir, don't say stuff like that, sir.
Don't die, sir.
Don't worry. Nothing much is likely to happen, but file unavailable. क्या बोल रहा है? कुछ तो लोचा हुआ. Okay. All right. So while I'm waiting for Google Forms to upload, let me just give you the exercise 4C. Which questions are coming from that, and then we'll work out. I'm trying to copy paste the email IDs of all of you all into the Google form and somehow it's rejecting it. Okay, looks like it's on its way.
You want me to forward it to everyone?
No, it's been done. Okay, I've sent it.
Okay.
So guys, just check your emails and well, you can actually actually you can do it right after the class, as you can do it after the last class is over as well. We have 10 minutes, so you should be able to do it. I don't have anything else to do right now, but the time is already 10:45 and Amrish sir's class will start in 5
So
seconds.
what about 4C? Like we had to discuss what questions we're supposed to do.
4C, right? I am ready with that. So from 4C assignment, you have question 1, 3, 7, 8, MCQ 2.
Only 4 questions.
Yeah, only 4 questions. and in numericals 1 and 2. Only 4 questions. It's a
In
short assignment. The
MCQs?
concepts are very little. MCQs, you just need to do the second one, and you will understand why I didn't give the first one when you do the assignment. So that's all for today. So I guess tomorrow we will start with critical angle and total internal reflection. And then let's see. Do you guys think that with the difficulty in kind of getting the class started, should we ask Amresh sir to reschedule his classes to 11 so we can go on till 11?
Yes, sir.
So it takes about 10 minutes to just set things up and get going. So I will ask Amresh sir to start his class from 11.
Sir,
Yeah. Who that?
but we have bio, right?
Sorry?
Bio then.
Bio classes are over, Baba. No more bio classes.
Oh, shh. Okay.
Okay.
Oh, sorry.
All right. So we'll stop now. If you have some time and Amresh sir hasn't come online yet, just you'll take 2-3 minutes to complete the quiz. So do get that done, and then we'll see. All right then. Bye bye.
Bye, sir.
Bye, sir.
Bye, sir.